Our next talk, and it's been alluded to a couple of times already, about the whole idea of integrating across these different functions, research, education, and extension. And to give that talk, and I want to, we had, I forget how we got to this place, I don't recall, but Rachel Melnick and Marty Draper and I sat down and talked about what we wanted to do with this talk, and it worked out really well because I got Marty and Rachel to do pretty much all the work, mostly Rachel, and they put together a really nice talk, and I think you'll find it very interesting. Rachel is a fellow with us and used to be with ARS as a postdoc, and I don't know how long she's going to be there, but we're tickled to death to have her. So, Rachel?
Okay, yes, I'd like to mention I was not the only person to put this talk together. Marty Draper, who is heavily involved in extension, both from the university aspect and as national program leader, did do a lot of help along with this talk. So I'm a AAAS Science and Technology Policy Fellow at NIFA, and why am I talking about integrated research? I am actually the program manager for the methyl bromide transitions program, which is an integrated program, so I have been getting some experience since I've been at NIFA. Where am I aiming? Okay, so research, education, as extension, as Marty likes to say, is a three-legged stool. Each leg is one of our concepts, and if any of them are missing, the stool falls over. You can't have a good project, an integrated project, where any of these components are missing. They all strengthen each other. And the history of this program is actually rooted in the land-grant system and the lessons that were learned in developing the land-grant system to the point it is today. So I'm going to give a little history of the land-grant system. In 1862, the Morrill Act created the land-grant university in every state. Now, this established the system, but did not provide ongoing support. So we had the education aspect, but not all the other aspects to go with it. So to strengthen this system, in 1887, the Hatch Act was created, and that was to actually provide federal dollars to support the land-grant system. So now we have the education adding the research to it. In 1890, another Morrill Act developed the 1890 land-grant systems at the historically black colleges. Again, much like the 1862 system, it developed the system but did not provide the ongoing support. So we had research, we had education, and as the system was getting developed, we didn't quite have the system to actually fully benefit the farmers. So in 1914, the Smith-Lever Act was developed to establish cooperative extension, along with state matching funds. So now we have the three legs of the stool finally created. In 1977, the National Agricultural Research Extension and Teaching Policy Act, and I like to say, as you notice, as the years go on, our acts get longer in name, was developed and put forth to provide funds for experiment stations at the 1890 universities. And in 1994, the Elementary Secondary Education Act developed land-grant system at tribal colleges. So through this system, you would think that the research, the road from extension to education and research was a very linear road. You developed education, we developed some research, we developed the extension system. Unfortunately, or fortunately, it isn't actually a straight system. It is much more like a traffic circle than it is like a road. You can enter at research, you can enter at extension, or you can enter at education. Sometimes going out and doing extension creates questions for researchers to answer. Other times, going through education, we realize that we need to do more outreach, we need to develop some programs. And then sometimes research does actually go from research to education to extension. But more often, it's much like a traffic circle. So another big component of our research, education, and extension is the stakeholder aspect as well. Questions arise at all of these points that may require you to go back to the others. It isn't a complete linear system, and that's the best way to think about it. You have to think about all aspects of this together. So in terms of education and extension, overall, the system has the same point. You're trying to provide information, but your target audience is different. For extension, your target audience is going to be your stakeholders. So it could be a wheat farmer in the Midwest. It could be someone who produces country ham in Virginia. But it's more of a stakeholder output. While your education for the grants is looking more at anything from children straight up to your graduate students. Especially in terms of childhood obesity, your education aspect may not be fully just educating graduate students. You may be developing programs that are going into preschool or elementary schools to help to educate the children to have better nutritional standards. It may be doing a program, and one of the examples I'll be talking about later is doing outreach and education to high school students to try to recruit them into agricultural science and just to educate them better about the science that's at hand. And traditionally, many of the grants, and which we more commonly would think of in education, is workforce development, providing money towards graduate students, but it could also be developing a curriculum for undergraduate students. So where does our education fit? It isn't a always straightforward, just one person aspect. It could be workforce development. Undergraduate research is a big aspect as well, not just graduate students. Having undergraduates working in the lab creates new graduate students, as well as gives them an aspect of what they may be doing in the workforce if they choose to go into the workforce. And I have myself advised many graduate students, and I have one undergrad who went right into Monsanto, who's making far more money than I am. So again, curriculum development K through 12, especially on hot topics. You know, if you can get a curriculum to a teacher, I have many friends who are teachers, about a hot topic such as childhood obesity or maybe climate change that they could use in their classroom or use in an outreach activity, would be an excellent example of this. And it could be even involving school children in field days. So in terms of developing integrated programs, we thought it would be best to actually provide examples of some of our successful grants and discuss different aspects of them on why they were successful and different ways they integrated research, extension, and education. So the first grant I'm going to talk about is actually I'm going to go from smaller grants to bigger ones, is a smaller grant going on preventing foodborne illness among vulnerable older adults through home-delivered meal programs, a multifunctional approach. This went to one investigator at the University of Maryland. And what she had done is she used this grant to partner with Meals on Wheels Association of America and the FDA Center for Food Safety and Applied Research. So the goals of this grant were to increase the ability of older adults to live independently at home. Meals on Wheels program actually provides food for homebound seniors. So they wanted to look at keeping the program going so that people who are capable of living at home are able to do so, but they also wanted to make sure that the meals that were provided to the senior citizens were healthy and that these people themselves were keeping good food safety standards in the house. So I actually went through and completed a survey of home delivery programs, going out into America and simply surveying, seeing what they were doing with food safety. And one of the aspects we want to talk about with extension is thinking about your audience. And this paper here really illustrates that in this project. They had surveyed 1,317 home delivery recipients via telephone. Because if you're looking at seniors, some senior citizens are very technologically savvy and could pick up their iPhone, and someone like my grandmother, just operating the cable box is a little above her. So going out and doing a telephone survey, you can reach a wide breadth of the audience without having to worry about technology. So they went through and they did a telephone survey using the FDA standards for their survey they had created on food safety. And they actually found that people who are older than 60 had better food safety standards than people who are under 60. And they also found that women who were high school graduate levels had better food safety standards than men who had high income and high education. So they figured that this was the specific people they wanted to make sure they did outreach for to have good food safety standards in the home. So once they knew about what was needed and the needs in the programs, as well as for the homebound seniors, they wanted to develop a training program to improve food safety from the meal to the home base. So they developed, this is actually on the University of Maryland Extension webpage. You can Google it and it'll pop up. They developed modules for everyone at every step in the food production process. Straight up from directors of the Meals on Wheels in a location, to food service managers, to the workers, to the volunteers who are putting food together, and those who are delivering the meals. They developed an annual training program that is available online, and they have train the trainer programs where they can go out and go to every Meal on Wheels site and develop a training program that is implemented. So you're training everybody annually to make sure food safety is present. And one of the other things in terms of extension I like that they did is they created a magnet that would go out once a year to the consumers of the food. You can put it right on your fridge. It is accessible to everyone, so as you're putting your leftovers in the fridge, you have your food safety magnet there. It's a very cost-effective way to do extension. A thing you want to think about with extension is how is it actually getting to your stakeholders? Here it is Meals on Wheels recipients. And in terms of education, they had trained a graduate student and a postdoc on the project. So this is a very small project that had a big impact in terms of education and extension and the research components involved. So the next example I'm going to talk about is a SDRI grant, Comprehensive Automation for Specialty Crops. One thing I want to point out about this grant is the project director is from Carnegie Mellon. This is a private university in Pittsburgh. Yet they have an integrated project with a large extension component through partnering with Penn State, Washington State, Oregon State, and Purdue. And they also partnered with industry components, Vision Robotics, DBR Conveyor Concepts, Toro, Trimble, and they also have partnerships with USDA ARS. So this is a larger project with multiple partnerships. The focus of this project is actually on apple and nursery trees, combines research, extension, and education, but it also combines multiple disciplines. We have research scientists from entomologists and engineers, electrical engineers, computer scientists, entomologists, extension specialists, sociologists. You know, you want to look at your extension, it's not just delivering what you feel is needed to the farmers, but it's also understanding what the farmers want to know, as well as economists on the project. So there are 3 components to this grant that they wanted to look at. One is crop intelligence, they deemed it. It is sensor development, insect monitoring, crop load scouting, caliper measurements of the trees, and information management. Another aspect that the engineering department was more looking at was to add automation to these nursery systems in terms of, I'll discuss them a little more later, mobility, positioning, and actually harvesting. And then technology adoption. And the key to technology adoption for this grant, I feel, was having the sociologist and economist on the grant, because they actually went out and talked to the farmers and determined whether there was value added in these products that were being developed. So for crop intelligence, one of the aspects they were working on developing was spectral imaging and sensor technology to detect pests and pathogens in the crop. And also they were looking at developing sensoring to detect stress of the trees. One of the more successful aspects they developed was these Wi-Fi Z-traps you see here. These are for trapping for entomology, for coddling moth and other insects. So as the insects go through the trap, they're pheromone-based traps. It's actually Wi-Fi. It counts the insects that are falling through, so you have an idea of your pest level in the orchard, and then it Wi-Fi connects back to your house, your computer. So this is implemented in the extension station at Oregon here. But when going through, and the sociologist did the survey and talked to farmers, 100% of farmers said they would use this trap. They compared it based upon the traditional trapping and counting, and they found it was adequate. And the farmers said that the investment in the traps in terms of dollars made sense in the time they would save. Again, you're looking at not only saving time, smarter pest management in your IPM. You're only going to spray when you really need to. So this is where having a sociologist and extension on the project was very beneficial. This is going to be adopted. They also looked at robotics to count, and then laser sensors for counting trees in the nursery in terms of research. Now, automation. This is another step where we found the sociologist was very important. So Carnegie Mellon actually developed, using these Toro little carts, automated carts that you can go through, and the farmers could use this during pruning and fruit tree thinning. This is where going to the farmers was important. So they developed all this, and of course, because they're computer scientists and engineers, I live with a computer engineer myself, they thought the greatest idea was, let's have an iPad mounted on this to drive the cart. Well, when you are in the lab developing technology like this, you don't have sunlight. So once they mounted that iPad, which you can actually see right here in the one, I'm sorry, you shouldn't let me have buttons. So I used to always say in graduate school, how many PhDs does it take to work a projector? A lot. Okay. So right here is the iPad mounted in direct sunlight. The farmers could not actually use the iPad to drive it because they couldn't see it. So they literally wanted a stick because you can see it, it's in all conditions. So they actually implemented this on farm in orchards using the extension service and the collaborations in Biglersville, Pennsylvania, which is Adams County, a big apple growing region, as well as in the apple growing region in Washington. Going to the farmers talking about them, they said, this is great. It runs at low speeds and the equipment can't handle it, and once we get to the end of the row, I have to wait 45 minutes to use it again. So this is where having the extension, actually going out and talking to farmers. The farmers found that this and the value added to it wasn't what they wanted. You know, the development was great, but they never would really want to use this due to technology issues that they could overcome, but simply because the cost wasn't effective. So the next for automation is actually developing an automated harvest system. One of the issues with apples, I am a tree crop pathologist, is actually when you harvest any of the tree crops like this, you have to be very careful. And the reason they hand harvest is when you get bruising, you have post-harvest issues in terms of pathogens entering. So they were looking at actually developing a system that would use vacuums that would be really gentle at harvesting the crops. And they did have some of these implemented in the fields. And this did take a few people to utilize, but they were thinking in terms of there may be an issue with the workforce in the future due to the immigration policies and other issues associated with harvest of fruit crops. Okay, so in terms of outreach and extension, they held field days, they had web pages, they went into their fields, they had multiple meetings with farmers. The extension component on this grant did not state we are holding a twilight meeting, and that is it. They had farmers involved throughout the process and at multiple steps and multiple outreaches. In terms of extension, in the 3 years, they had 68 different students involved. As you see, they have your typical graduate students. The Carnegie Mellon and Purdue graduate students were actually engineering students, not agriculture students. They were electrical engineers, computer scientist types. Carnegie Mellon had 30 undergraduates involved. They actually implemented classwork to help define these strategies. Penn State had different undergraduates involved as summer interns. 9 of those were not from land-grant schools. They were from state schools and private schools that actually came to do internships. So again, outreach to pour much less traditional students into it. I myself went to a state school, not an ag school, so outreach like this does work. And I'd like to also mention that Oregon State and Washington State University used community college students as interns, again, drawing more people into the science. So that was one of the successful projects, and now I'm going to talk about animal science. So in terms of this project, I'm going to talk more about how this was successfully put together. So there's going to be a talk at 3 o'clock or 3:30, actually more focused on this, but how do you get a large project together? So you want to identify a problem that impacts a large group or area. And this is porcine reproductive and respiratory syndrome virus. It is a pandemic to the swine industry in North America. It's also more commonly known as blue-eared pig disease. It has vertical and horizontal transmission. It's a lot of reproductive issues if a pig becomes infected. If you have infected pigs that are unable to reproduce, you have a lot of yield loss within your industry. The issue with this virus is it mutates rapidly, so vaccination has been very difficult to develop. And the animals also have a lot of respiratory distress. There's a lot of herd health issues. So once they identified this issue, they put together a multi-state project. So this was to get, you got the project together. It helped to develop your group. People started working together. They were able to talk to each other and develop relationships. So once you identify the issues and you can have this working group together, people can talk and think, wow, we need to research this and this and this. And then you have a group that's already working together, who already has research, extension, and education components. And from that point, you can think, gee, we really should put a grant together. Let's start working on this and lining everything out before the RFA comes out. So one thing in terms of any issue, not just viruses, is to recognize that many of the issues in agriculture do not have geographic boundaries. You know, a virus does not care if it is Virginia or North Carolina. It's gonna go right across the boundaries. You know, childhood obesity does not care if it is the South or the Northeast. None of those issues, the boundaries are there. So what they actually did is any area where they've been having problems with the virus, they've been getting researchers involved from these different areas. And this is going to be updated soon, but this is the project areas that were completed in 2012. So they have a lot of extension. This slide is really busy. I just kind of want to say that in terms of their extension outreach, they developed modules and trainings from everything from on the farm to the community and actually to veterinarians who are large animal vets going onto the farms. And in terms of education, the problem's going to continue no matter what problem it is, so you want to train future scientists to deal with it. So they developed a minority research initiative supported by the CAP, and they have graduate and undergraduate scholar program. And what I find, they have eliminations things. So if you're an animal science professor and you want to talk about this virus, you can actually click on this link and get educational materials. And they also have continuing education credits for veterinarians. Now, in terms of the geography, this program was so successful, they actually now are collaborating with scientists and research agencies in Canada as well as in the US. So they used their small multi-state to get money at a grant and then expanded it into actually being an international research program because, again, the virus doesn't care whether it's Canada or the US. So another successful grant program we have is the Sustainable Corn Cap. SustainableCorn.org is the webpage if you ever want to visit it and look over the research they're doing. This picture is actually all the personnel that are involved in the project from the annual meeting. So graduate students, postdocs, professors, education, extension research, everything is involved there. These are the different universities that are involved in the project. You may notice that the geographic location is in the Corn Belt because this is the main crop for the area. I do want to point out that Lincoln University is involved on this project. And their involvement is definitely not, as we were saying, people not getting enough money. If you look, Lincoln University is getting adequate support, and they are actually having a lot of scientists and graduate students involved on the project. And they are hosting a high school workshop this summer at the university. In terms of the people involved, I'm not going to mention all of this, but you have, it's climate change. It is transdisciplinary, so they have a wide range of scientists involved in the project, and also high school teachers as part of their education component. So when you're talking about the panel, and they're saying the key to having a large grant operate successfully is to have a good project director. The project director for this grant, as you may see here, it's a little blurry, is Dr. Morton, who is actually a sociologist. Her background is looking at farmers' view of climate change. So she has experience in it, and the key to this is she is extremely organized. She is the person who is getting everything going. She is talking to everyone, making sure everything is developed. And what they actually did to help coordinate the grant is they developed a Google sharing site. Everything, all the materials are available for them. They can hold meetings, the notes instantly go up on the site. Everything is open to them only, and those involved in the project, but it's a great sharing platform. She's extremely organized and has had everything well put together. And the principal investigator is more as what we would see in plant pathology as traditional scientists, but it allows to have this collaboration. They also hired staff on this project because it's simply a lot to deal with. And as you see here, these are just the different research regions where the projects are going on. It's not just conventional. You also have some organic systems, extended rotations, traditional corn-soybean rotations. It is looking at all aspects of growing corn. So how was such a large group put together? This is not just one multi-state committee. This was actually 3 multi-state committees that came together. What was unique about this is the teamwork and collaboration started long before the project. So we have field research and modeling, as well as farmer beliefs is what they were researching. It's not just going out in the field and looking at climate change and how it affects corn. How do farmers feel about it? And I was talking to the national program leader who is in charge of this, and she said what was interesting to her is farmers may not always agree with climate change in terms of the terminology, but they understand drought, and they know that temperatures are rising, and they know how that impacts their crops. So in terms of extension, it may just be using the right language when you're going into the field. So one of the successes that this program has is they actually have standardized their logos and formats on all releases, including student posters. And they have a webpage that has all their news releases, so you can see everything that's coming out. One of the things they developed were these speed science fact sheets. Right here on the right is a sociology looking at climate change, and here is actually soil diversity. As you see, the same bottom, the same top, but they let to have the university logo of the researcher on. So why did this group work so well together? Everything was decided well before they wrote the RFA and they came to the table. Previous collaborations, they already know how to work well together. And another thing they did is they answered the hard questions from the beginning. They set standards on how to handle graduate students and postdocs. They set standards on how to deal with underperforming team members, who's going to deal with them and who's going to boot them off the project. How are you going to deal with when your researcher leaves to go to another university? Are you going to replace them? All of those were answered before the project started, so you're not dealing with crises right at the issue. They have rules developed on publication order. They did rules to develop for poster order, and who addresses what objectives of the project, and who will lead writing the papers. And they actually listed what papers they think they could get about it, and which institute and which researcher is going to handle it. And one thing I really liked when reading about the grant is the modelers may not be going out into the field and collecting the data, but it actually says in the guidelines that if you're a modeler and you use another researcher's data, they will be on the publication to ensure that everything is going well. In terms of education, up to date, they have 8 postdocs, 36 graduate students, and 24 undergraduates involved. The graduate students have gotten together and formed their own collaboration group. They meet monthly, they talk about the research, and these are not just field researchers. There are sociology graduate students involved, extension-based, more basic research, the soil diversity I showed earlier, and they get together. And this is going to not only develop a future workforce, this is developing future collaborations in research, extension, and education. This is the people they're going to be working with for the future. Another interesting aspect they developed for education is a summer climate change course. It is a course for high school students. Ohio State held it last year, and they work with high school teachers to develop the curriculum. They have the high school students do a 3-week internship. And in terms of some of the farmer surveys, the high school students were actually going on farms and talking to the farmers, and it's just giving them a better aspect of the needs and issues with agriculture. And this summer, that's going to be held at Lincoln University. So key points overall that we can learn from those 4 grants is the grant needs to be a team effort. All members should be brought to the table from the beginning. You need to build the program before the RFA is released, as we talked about in the previous section. And integration isn't just important to get the grant. It's not because we have to say you have to do research and extension. It's important to our stakeholders and implementation of the research. So in terms of budget, someone asked how important the budget was. Budget should reflect a joint project. If you say you're doing research, extension, and education, and the researcher has 98% of the dollars, that's not a joint project. And the panel will look at your budget and say, that's not a joint project. They do see these things. Your budget is looked at. Extension and education is not free. I have a friend who just got an extension position at a university. He negotiated a truck as part of his startup process because he's going to be driving all over the state. And he's going to have to pay for gas. And you're going to have to pay for your extension bulletin printing. It's not free. Same with education. You're working with childhood obesity. Curriculum development is not free. Your outreach, whether it's a DVD or it is, a coloring book, is not free. So make sure that everyone who's at the table has adequate budget to do their research. And they, as we said before, the panel says they do know this. So in terms of extension has a greater opportunity for mid and long-term outcomes. Basic research does not generally change the behavior of a range of people. It's great that you know that this gene is turned on when, your rice is infected with a bacteria. That's wonderful, and that's very beneficial to research in the future. How does that benefit the farmer? What is it doing to growing rice? What is it doing for Americans and the world food supply? With extension, you're more directly going to have these long-term outcomes. Economic outcomes show business viability. On the grant looking at apple nurseries, the #1 thing farmers cared about was How is it impacting their productivity? Are they having more time at home with their family because of adopting this technology? And foremost, how is adopting this affecting their profitability? You know, if you adopt this great technology and you're not making more profit, why should they adopt it? That's what farmers really wanted to know. So economic viability is very important for them. And in terms of this, Extension gets to the who cares question. So who cares? Congress. All of our funds are appropriated from Congress. So they want to be able to see that their constituents are making money and having a better quality of life. So briefly, I'm going to talk about the logic model that was already discussed. It is a model to develop the work plan. If you want more information on it itself, there's the webpage on the bottom. Oops, I turned my own page over. So we do not require a logic model, but it's helpful for our panel managers. It's an advantage during the review process, and I have a little analogy to make. So if you have two proposals with a logic model, you can see that this is an apple, this is an apple. This one's red, this one's green, this one has a leaf, this one doesn't have a leaf. So if you have two proposals where one doesn't have a logic model, well, I can see that that's red and has a leaf. But when the reviewers have to go through and read through multiple paragraphs, it's like having to dig through the grocery bag to even get to the apple to see whether it is, what color the skin is and whether it has a leaf. So at that, I will take any of your questions, and if I can't answer it, there are multiple national program leaders in the room who can help.
Thank you, Rachel. Let's give her a hand.
Okay, question here from Clemson. It says the projects Rachel Melnick cited as examples are very interesting, and I'm wondering if the description or abstracts of these projects funded are online or not, so we can take a detailed look.
The abstracts of our funded projects are available online. If you go to the NIFA webpage and you actually look at the specific granting programs, there's actually a link that you can say click on funded abstracts and see all the abstracts available.
Will the PowerPoint be available also on the website?
These PowerPoints are
Yes.
up. Oh, I'm correct, right?
Let me, that was a great segue, by the way, because there's something I needed to say before we broke anyway, so this is a good point to interject it. For the individuals that, or groups, that are watching this virtually online, and apparently we had a little miscommunication here. Our camera work is really focusing on the speaker, so the audio video, so the slides aren't really showing up well, so you need, if you're watching online, you need to open up the PowerPoints, which are available on the website, you know, right now, and then have two windows open, one with the PowerPoints and the other with the speaker. So just an FYI on that. And I'm sorry that we didn't catch that sooner, but this is a good time to interject it. We have another online question.
This one is from Northern Colorado. Hi, Rachel. I'm pasting some information from the RFA seed grant applications proposing an integrated project. Only need to include one of the three functions, research, education, extension, and justify how the seed grant will allow the applicant to become competitive for future integrated project funding. I guess this is the question here. If a seed grant will be submitted, would it be better to propose a project that will lead to an integrated project? Would it make the seed grant more successful?
It's hard to say what the panel will think about it. Has anyone had involvement in the room with the seed grant program? Mary? Huh? It's Mary Pete just said she will be talking specifically about that more this afternoon at 3? 3 to 3:30, she's actually specifically discussing that program.
I think probably the quick answer on that is yes. If you can show that a seed project's not going to be a dead end, that it's going to go somewhere, whether it be integrated or further research potential, you're going to have a better shot at getting funding.
We just had a suggestion to reread the RFA to make sure that they understood how the RFA was written as well.
We have a few more minutes for questions. Do we have any others? You're closer. Rachel, you're closer. Run over there. I can't be everywhere.
Is extension defined specifically as university extension, or any outreach activity can be considered as extension?
I believe it depends on what the outreach activity is. If you're doing outreach activities that may focus more on developing curriculum for children, that may be an education aspect. I think it just depends on who your stakeholders are. Who are you educating? Are you looking at a commodity group? Or are you looking at children or college or high school students? And that's kind of where it gets, as my one slide said, education and extension are the same concept. You're providing information. It just matters on who is your audience.
Any other questions? If not, we get a couple extra minutes, maybe 2 or 3 for our break. And I want to thank you again, Rachel. That was very, very helpful talk.